Hello students, in this session I am going to cover what is qualified association, how it is included on class diagram, then next certain graphical notations related to class diagram, its briefing and case studies on class diagram. Qualified association. The qualifier is a specialized attribute that reduces the effective multiplicity of more than one association on a class diagram. A qualified association in the UML is equivalent of programming concepts like associative arrays, maps, or dictionaries. Now see here example, country is one class and its associated class is citizen. Country and citizen. These are two classes. One country has many citizens. One country has many citizens and that citizens are identified by a unique number. That unique number is Aadhaar number. Now if we are talking about specific citizen, so on many sides this multiplicity is reduced by introducing a qualified association on a country here. So on country class we are introducing one of the special attribute, that is a Aadhaar number. This Aadhaar number is borrowed from this citizen class. So on this country class we are adding one specialized attribute, that is Aadhaar number, and we are searching for that specific Aadhaar number. For example, for search mechanism I have given the Aadhaar number as a 1234. So this 1234 Aadhaar number is searched along with the data of citizen class here. So that 1234 Aadhaar number might be present in citizen class or might not be present. So search result is either a 0 or a 1, means we can get that Aadhaar number. If exists, then we get a true result, otherwise we will get a false result. So on this many side we have reduced this star mark, that is this effective multiplicity of many association is replaced with a qualifier or qualified attribute. That qualified attribute is Aadhaar number. So we have introduced this attribute as a qualifier along with this particular class country. Like this we can introduce a qualified association on a class diagram. One more example for qualifier or qualified association. We have one class as a bank and another related class as a account. Now how it should be retrieved? One bank has many account. One bank has many account. So if we are not introducing or we are not giving qualifier, so that diagram looks like this. Now we are talking about one specific account number, so that account number should be a qualifier and that should be included on a bank side. So on bank side we are giving a account number. Now for example, I am searching for account number 100. Account number is 100. So that account number 100 might be present in account class or might not be present in a account class. So if it is present in account class, means that account is exist in account class, then we will get a true result, otherwise we will get a false result. So this many side multiplicity is effectively reduced by introducing a qualifier along with this one side here. Okay, so account number is added as a qualifier along with a class bank. So this is an example of banking system without qualifier and with qualifier. So the major role of this qualifier is it reduces the effective multiplicity, and we are talking about a specific object or specific record by introducing a qualifier. Up to this we have discussed about different notations used for drawing class diagrams, then certain common mechanisms, certain concepts which we can include on a class diagram. So this is about a structural modeling. Structural modeling shows a static part of software system, and it gives the conceptual design. Now class diagram. A diagram is one of the main building block of object-oriented modeling. It is used for general conceptual modeling of the structure of any application and for detailed modeling translating that models into programming code. Class diagrams can also be used for data modeling. It gives an overview of a software system by displaying different classes, attributes, operations, and their relationships. This diagram includes class name, attributes, operations in separate designated compartment. Class diagram defines different types of objects in the system and the different types of relationship that exist among that classes. It gives a high-level view of an application. This modeling method can run with almost all object-oriented methods. A class can refer to another class. A class can have its objects or may inherit from other classes. Class diagram helps to construct the code for any software application development. Here are common notations which we can include on class diagrams. Class can be represented by a rectangular box with a 3-compartment first compartment, and in center we can give class name as a singular noun, then second compartment attributes, and third compartment operations. One more notation for class, just we can draw a rectangular box and in that box in center we can give class name. And third notation for class, we can write a class name and set of attributes in second compartment or set of methods in a third compartment. Then template class along with a template variables at the top, that is shown by this dotted symbol. Then object represented by rectangular box. Then certain items can be included, packages, interfaces, aggregation, dependency, composition, generalization, association, binary relationship, binary association, then different parameter classes, n-ary link, n-ary association, multiplicity, then constraints, note. These are the various graphical notations which we can include on class diagrams. Now here I am discussing one of the simple case study related to class diagram, that is order processing system. For any order processing, the majority classes are customer, product, stock, and order. Now we are trying to map these classes with different associations. Here is a class diagram for order processing system. The first major class we have identified, that is a customer class. For customer class we have attribute set as a customer ID, customer name, address, and phone number. All are private members, so minus sign is attached and respective data types are mentioned after a colon symbol. Then set of operations for customer class is add customer, edit customer, and delete customer. Like this, a customer class is designed. Same way the remaining classes are designed, that is a order class, it holds order details, product class, it holds the product details, and stock class, it will hold the product and order details. Now how this diagram should be retrieved? 0 or more customers places one or many order. Then that order may contain different products. Okay. Then that products are kept in a stock. So stock is a major class and its subpart is a product. A stock is having different products. So here we are using a aggregation symbol, and also along with the stock and product class we are using a aggregation symbol, that is a empty diamond. Like this, different mechanisms, different components can be included on a class diagram. This is a very simple and basic examples. So here classes are drawn, multiplicity is shown, and a simple association is shown, as well as aggregation is shown for this respective classes. This is the example for order processing system. Now one more case study for class diagram, railway reservation system. In railway reservation system, the majority classes are railway system, passenger, train, ticket, payment details, and clerical person or a clerk. So these are the majority classes are identified. Now we are going to map these classes and we are showing the association with the different rows of the respective classes. See here railway reservation system. Now railway reservation system, for that we have identified the attribute as a ID and response as its operation. Now how we can retrieve this? One railway reservation have one or many passengers. One passenger or one or many passenger books one or many tickets. One passenger ticket cancels. One passenger cancels one or many tickets. Then one passenger or many passenger makes a one payment here. Then 0 or more passengers search for the train details. Then clerical person here, clerk works for this railway system. So in this example, we have shown major classes, we have shown the association between the classes, then role name, direction, multiplicity, and different methods required for that respective classes are shown here on a railway reservation system. Like this, we can solve n number of case studies for class diagram. So in this presentation, I have covered what is qualified association, how to give qualifiers on class diagram, then what is class diagram, its basic information, and two case studies I have solved here. First one is order processing system and second one is railway reservation system. Thank you. Have a nice day.